Hi. I'm sure you're having a really good day. I thought it would be fun to make a series on sorting algorithms, so I decided it would be great to start off with this particular one called the bubble sort. I'm really excited to bring to you this series, and I'm hoping you are too. Without any further ado, let's get started. So, now that we are going to get started with the sorting algorithm, it is important for us to know what we understand by sorting first. In simple terms, sorting refers to the arrangement of a collection of items in a particular order. I guess this term does not require any further elaboration as the word itself is self-explanatory. In this video, we'll consider an array having 5 different numbers and look at how these numbers can be arranged in ascending order using bubble sort. So, I have this array, 5, 4, 3, 2, 1, having 5 different numbers, and we see that these numbers are arranged in descending order, quite the opposite of what we want to do with the numbers. It's worth mentioning that taking the worst possible combination to understand an algorithm is the best way of realizing it completely, at least according to me. Okay, so, let us first understand how we are going to go about sorting our numbers. The idea behind bubble sort is that we will be sorting different chunks of numbers, from the largest chunk to the smallest one. And by the time we have finished doing this, our array will be sorted. Simple, isn't it? Let's go deeper. Let's consider the first chunk, that is, 5, 4, 3, 2, 1. In order to sort this chunk, we'll be checking every 2 consecutive numbers and swap them if the first one is greater than the second. We see that 5 is greater than 4, so we swap 5 and 4. Now the array becomes 4, 5, 3, 2, 1. The next set of consecutive numbers has 5 and 3. Since 5 is greater than 3, we need to swap them. The array now becomes 4, 3, 5, 2, 1. Next, we have 5 and 2. It's a no-brainer that 5 is greater than 2, so they're swapped. The array is 4, 3, 2, 5, 1. Now, the last set of numbers is 5 and 1. We know this. Obviously, 5 is swapped with 1. The array now becomes 4, 3, 2, 1, 5. So now, we have successfully completed our first pass. Let's now proceed to sort the second chunk, that is, 4, 3, 2, 1. 4 is greater than 3 and these numbers need to be swapped. The array is now 3, 4, 2, 1. I hope that now, it is obvious what the next step should be, so we'll just skip to the end of the second pass. At the end of the second pass, the array should read 3, 2, 1, 4. The next chunk will be 3, 2, 1, and after doing the required swapping, the array will be 2, 1, 3. So, this process continues until we reach a chunk having only one element. The fact that we reached this chunk indicates that the array of numbers is sorted and we are good to go. Since we do not consider the chunk having only one number as a pass, it only implies that if we have an array having a fixed number of elements, say n, then n-1 passes are required to completely sort the array. This fact tells us why bubble sort is not that efficient. Okay, I guess that now completes this video, and hope this has been a really smooth tutorial to learn from. Stay tuned for the next video where we'll try testing this algorithm in a programming language. Before you go, did you know this fact? Former Google CEO Eric Schmidt asked President Barack Obama once during an interview about the best way to sort 1 million integers, and Obama, pausing for a moment, then replied, "I think the bubble sort would be the wrong way to go." Well, bye for now and see you in the next video.